All right, we're back. We're still on page 2 of notes 10 of Calc C. And we are writing Taylor series from series that we already know. So we don't want to like go back to scratch. We don't want to like make a table. We want to use something we already know. So to do that, you have to like look through and be like, what's the thing I know? So like here, I know I can definitely write a series for cosine of 3x because I can write a series for cosine. And then I'll just multiply by x. So that's my game plan. That's what I'm going to do. So cosine of 3x, I'm going to just go for it. Cosine of 3x. All right, cosine's even. 1 minus. It's like the quantity 3x squared. So that's 3 squared x squared over 2 factorial. Plus the quantity 3x to the 4th. So that's going to be 3 to the 4th, x to the 4th over 4 factorial. Minus the quantity 3x. I assume I'm doing 4 non-zero terms. I don't know. Yeah, it looks like it. All right, the quantity 3x to the 6th. So that's 3 to the 6th, x to the 6th over 6 factorial plus dot, dot, dot. And then plus. So negative 1 to the n is just a part of it. We're going to get 3 to the 2n, x to the 2n. So I'm not working that out from the pattern. I'm thinking to myself, the nth term is u basically. So it's negative 1 to the n, u to the 2n over 2n factorial. So the quantity 3x to the 2n. So 3 to the 2n, x to the 2n. So I didn't like look at the, I think a lot of people, when they get to the nth term, they're like, all right, let me look at the terms and like work out what's happening. That's not really what you do. That works, but it's not really what you're doing. What you're really doing is you're just thinking like, each of these came from the fact that you knew the nth term and you were using it to generate them. So now we just multiply this by x, just cosine of 3x. So it's x minus 3 squared x cubed over 2 factorial plus. I have to like really be careful when I do this because it's like my mind just really wants the exponent of the variable, so the exponent of x and the factorial to be the same, like just really want that to be true. But it's not in this case. Plus dot 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 plus. Really excited. I'm having Pokeball tonight. I'm having Pokeball. I don't know where it's coming from. I think it's like Poke time maybe, or Poke something. So good. That's what I'm thinking about. We're too far away for you to share with me what you're thinking about, but probably something like that. What's for dinner, you know? All right, and then we just take the nth term from here. So negative 1 to the n, 3 to the 2n, x to the 2n plus 1 over quantity 2n factorial. So this 2n factorial in a vacuum, if somebody was like, what function does this thing converge to? And I don't know ahead of time, I'm seeing 2n factorial and I'm immediately thinking it's cosine of something. And now the question is like cosine of what? Well, when you do that, it should be 2n factorial, and then it should be u to the 2n. So you look for things to the 2n. I have 3 to the 2n. I have x to the 2n times x to the first. So just like ignore that x to the first. So I have 3x to the 2n. So now I'm thinking cosine of 3x. But then what about that times x to the first? Well, it's just times x to the first, cosine of 3x times x. So that's, you want to be able to go in both directions, and that's how you start getting familiar with that. Cosine of 5x, you kidding me? What order are these in? 1 minus 5 squared x squared 2 factorial. 5 to the 4th. X, like, why was this one not first? 5 to the 6, x to the... And it's like I complain about things and I think I should change them. But also, I'm spending hundreds of hours making these videos. And so even if I do change something, I'm going to have to like leave this like a copy of this somewhere, right? Because I can't change the notes and not have these available to people who are working through them. So that's unfortunate. And it's like, if I were a team of people, I might have looked at them ahead of time and like decided like, oh, I should make changes. And you could make the case that my students over the years have been that team of people. And yep, you're right. If you look at my inbox, like my personal email inbox, I probably have hundreds of emails in there. Almost all of them are from me. And they're from me, and what I do is I email myself the changes that I need to make to the notes, but then I just never do it. I never get around to it. All right, I'm gonna do one more of these, and then I guess, and then I'll come back and do the rest of this, because I suspect this problem is gonna be quite a bit of work. So I'm gonna do one more of these, come back, and do the rest of the page. So here we go. I'm gonna start with, so what do I know a series for? I know a series for e to the x. I'm gonna do this. Start with that, just write it down. So e to the x, we're gonna build this series. 1 plus x squared over 2 factorial plus. So I actually need one more term if I'm gonna have 4 non-zero terms and the nth term when this is done. So, but that's like the kind of thinking ahead that when you're first learning this stuff, you do it wrong and then you go back and fix it. Like you don't have the brain, the like, it's not that you don't have the brain power. You don't have the processing power available at the moment to think through on that level. And that's fine, it takes a while. So we're gonna subtract 1. Now we're subtracting 1, not like 1 from everything, just 1, right? So if I subtract 1, it just knocks that off. So that's why I wrote more terms than maybe you were expecting. I went one farther than it seemed like I should because I knew I was about to knock one of them off. And again, nobody expects you to do that, you know, in one shot the first time. Now what we're going to do is divide everything we see by x, and we will have done it. So everything, what am I doing? Everything you see by x. So I gotta write this again. X minus 1 over x. Okay, everything you see by x, right? So it's like a giant division bar x, right? We only had 1 to subtract, so that knocked this off. But we're dividing every term by x. So this will be 1 plus x over 2 factorial plus x squared over 3 factorial plus to the 4th over 4 factorial. Plus plus, so x to the n divided by x is x to the n minus 1, n factorial plus . But we divided by x, and what are you not allowed to divide by? You're not allowed to divide by 0, so at this point we need to say comma, x is not 0. That's a thing, right? So polynomials are defined for all x. So you have to really watch out for domain restrictions because once you write your series, which is essentially an infinite polynomial, it's fine with anything, right? So we have to let it know if there are values it's not supposed to work with. And so we say x can't be 0 in that case. And then our summation is going to be some, so we should just be able to take this. It's x to the, oh, I see a problem. We knocked off the term that came from n equals 0. Right, the 0 term was this. We knocked that off when we subtracted, so we should start at 1. And what I really was doing was as soon as I wrote 0, I then like mentally checked, and that would give me x to the negative first, and it's not supposed to start there. So really, this is what told me that I should be starting at 1. Not the fact that it's 1, the fact that it's not x to the negative first. That's why I decided to do that. And then put in our restriction that x cannot be 0. And there you go. All right. So, yeah, I'm going to stop this video here. I'll come back in the next one and finish the page. So I will see you there.